Hello students, good morning to everyone. This is Murali, your maths mentor. I welcome everyone for today's online class. In this uh, lecture, we will be discussing about the new topic is called permutation. It is a part of algebra. So without any delay, let's begin the topic permutation. The basic meaning of the permutation is nothing but the arrangement. Okay, the basic meaning of the permutation is arrangement. It could be the arrangement of letters, arrangement of numbers, arrangement of persons in all possible ways. So the basic meaning of the permutation is nothing but the arrangement. Now let's take an example to understand what is the meaning of this particular name arrangement. Okay. Now let's suppose A, B, C are the three persons. Let's suppose A, B, C are three persons. Now let me see how many ways these three persons can stand in a line or stand in a line exactly. So this is a one position where A is standing in the first place, B second, C last. Now A fix and interchange these two, C B. Now fix B in the first place, B C A. Again B in the first place, A C. C in the first place, A B. Again C in the first place, B A. That's it. So therefore, now let me check how many arrangements I got. 1, 2, 3, 4, 5, 6. Now, is there any other possibilities? No. All the different arrangements were we got in this case, in this arrangement. So therefore, if three persons were given, they can stand in a line in six different ways. 1, 2, 3, 4, 5, 6. Okay, there are six different arrangements we can get if three persons were given. Okay, fine. So the total number of arrangements are 6. Fine. Now let's suppose if I have given 10 persons, let's say A1, A2, so on, A10. 10 persons are given. Now can you find out, can you tell me how many different ways these 10 persons can stand in a line? How many ways these 10 persons can stand in a line? Now here in this case what happened, because we have only three persons have written the different possibilities on a piece of paper. I got the totals arrangements are 6. But here is it possible to write all the different types of arrangement on a piece of a paper? It's very difficult. Of course it is possible, but it's a lot of time it will take. Then how do you get the total number of arrangement in this case? So here, so finding the total number arrangement in this case is become difficult. So in order to overcome this problem, we need a principle. We need a principle that is called counting principle. What do you call? Counting principle. The advantage, what is the advantage of the counting principle is, by using this counting principle we can find out the total number, of arrangement without actual counting or without actual writing the arrangement on a piece of a paper. Okay, so by using counting principle we can find out the total number of arrangements without actual counting. That is a basic usage. So first we will learn the counting principle, and after that we will discuss how we will find out the number of different arrangement in this case. Okay, now let's move on to the very important one is counting principle of multiplication. There are two types counting principles further. One is counting principle of addition and the other one is counting principle of multiplication, but we will discussing the counting principle of multiplication. Okay, so counting principle of multiplication, counting principle of multiplication. Okay, right. Now let's see what is the meaning of this counting principle of multiplication. Now what is this statement, what is this principle saying? That let us suppose if an operation, let's say if an work, let's suppose if an work A can be done in M ways. First, let's suppose the work A can be done in N ways, and another work, let's say another work B can be performed in N ways. I think but this work A can be done in M ways, another work B can be done in N ways. Then the total number of ways where both A and both the works A and B can be done simultaneously. Both the works A and B can be done simultaneously, can be done at a time. Can be done at a time is m into n ways. M into n ways. This is a counting principle of multiplication. It's very very important because most of the problems in the permutation we will be using this counting principle of multiplication. Okay, let me see. If an work A can be done in m ways, another work B can be done in n ways, then the number of ways both the works A and B can be done at a time is m into n ways. So to understand this, let's take an example. Okay, let's take an example from one daily life situation to understand the meaning of this counting principle of multiplication. Now let's suppose a student has a birthday. Okay, he has a birthday. He went to a shop to and he purchased three shirts. He purchased three shirts and two pants. He purchased three shirts and two pants. Now let me find out how many ways he can dress up for his birthday. How many ways he can dress up his birthday. Now here, since he want to be dress up for his birthday, he has to perform two things. He has to complete this work. He has to wear the shirt as well as he has to wear the pant. So here both the works has to be done simultaneously, one after the other. Okay, now here, now let's see how many ways he can choose the shirts. How many ways he can choose a shirt, because he has three shirts are available. He can choose any one of the shirt in three ways. So therefore the number of ways choosing the shirt, choosing shirt is three ways, because he can choose any one of the shirt out of three. Because in this two works has to be done. He has to wear the shirt and wear the pant. He has to wear the shirt as well as pant, then only his work will be completed. Okay, now let's see how many ways this work can be done. So the number of ways he can choose a shirt is three ways. Now let's see a number of ways he can choose. Choose a pant in how many ways? Two ways, nothing but one operation. One work is can be done in three ways. Another work can be done in two ways. Since my task is completed, depend on if both the works has to be performed simultaneously. So as per the counting principle of multiplication, the number of ways he can dress up, number of ways he can dress up for his birthday. He can dress up for his birthday is 3 into 2 way, that is 6. Nothing but he has to perform this. He has to wear the shirt, which can be done in three ways, and he has to wear the pant, he can done two ways. So first operation can be done in m ways, another can be done in ways, then both the things has to be done simultaneously, m into n, in 6 ways. Nothing but he can dress up for his birthday in 6 ways. Now I will show you what are the 6 ways. On shirt 1 he can wear a P1. On shirt 2 he can wear a P1. On shirt 3 he can wear a P1. Or else on shirt 1 he can wear a P2, on S2, P2, S3 and P2. So therefore there are 6 different ways he can dress up for his birthday. So total how many? 1, 2, 3, 4, 5, 6. Yes, 3 into 2, 6. Very simple. So if an operation perform m ways, another operation can perform n ways, then the total operations can be done simultaneously m into n ways. Here, because here both A and B has to be performed, means he has to wear the shirt and pant. Whenever use the word and, so just use the multiplicative operator to get the total number of arrangements. Okay, this is the counting principle of multiplication. Okay, right. Now let's see how this counting principle of multiplication is useful in solving out the earlier problem. Achha, before that, let's suppose I have let's say A1, A2, A3. Okay, A1, A2, A3. Now let's see how many ways these four persons can stand in a line. Okay, how many ways these four persons can stand in line. Since four persons are standing, I need four places. Okay, now my task is completed only when first place and second place and third place and fourth place is filled up. Means here four works has to be done, right? Okay, now let's see. Now tell me how many ways, now here how many ways this place I can fill, because since four persons are available, this first place can occupy any one of the four persons. So here this place can fill with any one of the four. So the filling of the last place can be done in four ways. Now still how many left? Three persons. So this second place can be filled in three ways. Now this I can fill in two ways, and this I can fill in one way. So therefore one operation occur n ways, another n ways, p ways, q ways, according to counting principle of multiplication. Because my task is finished only when filling a first place and second and third and fourth. I'm using the word and, so in this case you have to use a multiplicative operator. So therefore the total number of arrangements are 1 into 2 into 3 into 4. Therefore fourth is a 12, 24. So therefore I'll get total 24 different possible arrangements in 24 different arrangements. So arrangements of standing of these persons. For example, if I say find the total number of arrangement in which A1 is not sit in the A1 is not sit in the last place. Understand my question? Find the total number of arrangement in which A1 is not ready to occupy the last place. Is not means he is not he never preferred to sit in the last place. Nothing but how do you find out in this case? Since A1 is not preferred to sit this last place, nothing but this place I have to fill with either with the A2 or A3 or A4. So therefore this last place I can fill with either this or this or this. So therefore filling of last place can be done how many ways? Three ways. Now here A1 can sit anywhere else. Now by this I have filled only one place with one person. Now still how many are left? Three. So this person, there is no issue here. This person, this place I can fill with remaining three persons, and this I can fill with remaining two, and this is remaining one. So therefore one, what is this? The total number of arrangements, the total number of arrangement of these four per persons in which A1 is not at the last place. So the question is, okay, I'll write the number of arrangements, in which A1 is not in last place. So here since A1 is not ready to occupy the last place, so nothing but the last place I have to fill with remaining three persons, A2, A3, A4. So this place I can fill with three ways. Now by this only one person is filled up. Now out of four, one is have filled up. Now still three left. This I can fill in three ways. For filling of this place, two ways. Filling of this in one ways. According to counting principle of multiplication, the total number of arrangements are 1 into 2 into 3 into 3. Okay, 3 is a 9 to the 18. So therefore I get total 18 arrangement. 18 arrangement. See, I think you might have seen the major advantage of this counting principle of multiplication is I am able to get the total number of counting without actual writing the arrangements on the paper. Okay, okay children, I hope this one is clear. Now let's yes, now let's take one more problem. Now the problem is let's suppose here I have 1, okay, 0, 1, 2, 3, 4, 5. Okay, now we have 0, 1, 2, 3, 4, 5. Total 6 numbers are available, 6 whole numbers. Now my question is find the number of 4-digit even number. 4-digit even number. Okay. Find the total, yes. Find the total number of 4-digit even number, okay, by using this without repetition, since I need to get a 4-digit number, nothing but I need 4 places. And my task is complete only after filling the first place and the second and the third and the fourth. Now, since it must be a even number, the last digit has to be filled with even number only. Is last digit should be even number. So now tell me, the last digit has to fill with even number. Now let's see how many even numbers are available in my set. So this is 1, this is 2, this is 3, nothing but last place I can fill with any one of these 3 numbers which are even. So this place I can fill in 3 ways. Okay, fine. Now here I can fill with any other number this place. So by this I filled only one place with one number. So now still 5 left. Among this I can fill in 5 ways. This I can fill in 4 ways. Now this I can fill in 3 ways. Now once you see here. Now in this arrangement, there is a possibility that some of the arrangement can start with this 4. Okay, because now here I'm writing one arrangement among this. So I'm writing one arrangement of this category. So this even number, okay, this place has to fill with even number, nothing but 2, let's say something 4, let's say something 5 and 0. So nothing but this is one arrangement which is belongs to this category. This is one type of arrangement which belongs to this category, but this is an even number, but it is not a 4-digit even number. So therefore among these arrangement I need to remove this category, these numbers. So what these numbers? These are the 4-digit numbers. In fact, it is 3-digit number. So assume these are 4-digit number which starts with 0. So from this you take out the 4-digit number which starts 4-digit and even number start with 0. Okay, so from this we have to remove. Okay, we have to remove this case. Okay, so from so actually how many arrangements here? 3 into 4 into 5 into 6, nothing but 3. How much? 12 5s are 60. Okay, 3 4s are 12, 60, 63 is a 180. Among those 180, these type of cases are included in this. So I have to eliminate these type of cases. So from this remove or eliminate the 4-digit of course 4-digit even number starts with 0. Now how do you remove? It's a 4-digit even number starts with 0. Let's find out how many 4-digit even numbers start with 0. Start with 0 means this first place I have to fill with 0. That is only one way. The first place I can fill with 0. Only one way. And it should be even number. Even number, it nothing but the last digit has to fill with even number. So already 0 is allotted here. I cannot put 0 again there. Still how many left? 2 and 4. So this last place I can fill with 2 ways. So by this I have filled the first place and last place. So with this I have filled only 2 places with the 2 numbers. Total 6 out of 6. 2 numbers I have utilized. One is the first place, one is the last place. Out of 6, 2 numbers I have utilized. Now still 4 left. This I can fill with any one of the 4 numbers. And this I can fill with any one of the 3 numbers. So therefore, this is how much? 1 into 3 into 4 into 2. That is nothing but 4 2s are 8, 8s are 24. Therefore, these are the 24 numbers which starts with 0 and 4-digit even number. So among those 180, you have to remove this. So therefore, the total number of 4-digit even, the 4-digit even numbers, 4-digit even numbers are, in this case, is 180 minus 24, and that will be around 156. Total 156 arrangements. Okay. Okay, so this is the uses all the problems we are doing by the counting principle. So very basic thing. What is counting principle? If one operation occur in base, another n base, the total number of operations can be occur is m into n base. So all these problems we have done by using the counting principle of multiplication. Now one more problem. I hope it is clear to everyone. Now let's see the one more problem. Okay. Now one more problem. Now here's a problem. Now let's suppose you have numbers 1, 2, 3, 4, 5, 6. Okay. Now the question is find the number of five 4-digit even number. Okay, 4-digit even number which are divisible by 3, which are divisible by 3. Repetition is allowed. So asking find the 4-digit, sorry, it's not even number, 4-digit number which is divisible by 3. Each digit can occur any number of times. It should be 4-digit number, it should be divisible by 3, and each number can occur any number of times. See, what is the rule for divisibility by 3? As we know, a number is divisible by 3 if and only if sum of the digits is divisible by 3. Okay, right. Now let's see, it's a 4-digit number, so I have to allot 4 places. 1, 2, 3, 4 places. So now sum of all these places should be divisible by 3. Now let's see how can get this 4-digit number. Since here each digit can occur any number of times, here the first place. Okay, the first place I can fill with any one of the 6 numbers. So the filling of first place can be done in 6 ways. Now second digit 6 ways. The reason is what? Each digit can occur any number of times. Now this in 6 ways. Now the issue will come, how do you fill the last place? Now remember, you have to fill the last place in such a manner sum of all these numbers should be divisible by 3. Now let's suppose here x1 is allotted in the first place, some number is occupying the first place. Let's say x2, x3. Now let's see how do you fill this x4. Now see Nana, if you add these numbers x1 plus x2 is x3. Okay, now this is x4 actually. Okay, now here if add these three, you'll get some sum, and if you divide that sum with 3. Remember, whenever any number is divisible by 3, reminder you get either 0 or 1 or 2. That's it. So here x1 is a number which is allotted in first place. Okay, x2 which is allotted in second place, x3 which is allotted in third place. So when I add these 3 numbers, you are going to get sum. That should be you are going to get sum. Okay. Now that sum, now you divide that sum. If you divide this sum with 3, you get either remainder 0 or 1 or 2. Okay. Now let's suppose if this number is exactly divisible by 3. If this is exactly divisible by 3, nothing but even this place also should, this one also, since it is divisible by 3, means this last place should occupy with 3 multiple. Okay, so in this case the x4 I can fill how many ways? X4 I can fill with 3 multiple only, that is 3 or 6, nothing but how many ways? 2 ways. Let's suppose if x1 plus x2 plus x3 is if you divide with 3 or else it is a 3k plus 1 form. 3k plus 1 form, nothing but if x1 plus x2 plus 3k plus 1 form, nothing but this is a number when divided by 3 leaves remainder 1. Okay, if leaves remainder 1, nothing but this is 3k plus 1. If the number is 3k plus 1 form, and now can you tell me how do you fill the last place? Because we are looking for the sum of all the digit should be divisible by 3, means x1 plus x2 plus x3 plus x4 should be 3k form, 3 multiple. So since it is 3k plus 1 form, nothing but the last place you have to fill with either with 2, because if you add 1 plus 2 you get 3 multiple, or you add with last place should fill with 5, 2 or 5 is clear. The last place, nothing but 2 ways. Or if x1 plus x2 plus x3, if it is 3k plus 2 form, if it is 3k plus 2 form, now can you tell me the last position I should fill with either with 1 or 4, because if you add 1 it becomes 3k plus 3 multiple. Even if you add 4, 3k plus 6, 3 multiple. So nothing but if the sum of these three numbers is either 3k form or 3k plus 1 form or 3k plus 2 form, the x4 can be filled in how many ways, children? 2 ways. So this is, I can fill only 2 ways. So therefore I can say the total number of number of 4 digit number which is divisible by 3, each digit can occur any number of times, is 6 cube multiplied 3. Okay, 6 cube multiplied 3. So this is the advantage of the fundamental counting, the principle. I hope okay, let's I hope this problem is clear to you. Okay, we will discuss some other problems in the next session. Thank you very much for listening my class.